one way to figure this out is, suppose you have a 3 by 3 matrix, A, B, C, D, E, F, G, H, I, and then you multiply 1, 0, 0, what do you get? A, and then D, and then G, right? So multiplying 1, 0, 0 picks up the first column. Multiplying 0, 1, 0 picks up the second column, and so on and so on. Is that okay? All right. So here's how you make use of that fact. First of all, think about what 1, 0, 0 is in terms of this basis B. Right? So what is 1, 0, 0 in terms of basis B? 1, 4, 1 in terms of basis A, right? Is that right? Is that right? Okay. So if I want to know what T B to B of 1, 0, 0, since this is acting on basis B, the vector you write here has to have the same basis, or else the multiplication will be illegal or it's meaningless. All right. So if I want to do this, right, then this is like taking T and then multiplying by 1, 4, 1, and then writing down the result in basis B. Okay. What I'm trying to say is that if you have T basis B to B of another vector V on basis B, this is the same thing as applying TV and then representing the answer in basis B. That's what I'm saying. But what does 1, 4, 1 do? Well, since A is the standard basis, 1, 4, 1 is really easy to write in here, right? So I can see that T applied to 1, 4, 1, if you work on the base coordinate A, or basis A, it will be like 2, 1, 0, 0, negative 1, 2, 0, 3, 0, multiplied to 1, 4, 1, okay? And then rewriting this, well, yeah, this will be just already in basis A. This is already in basis A. Let's calculate it. It's 2 plus 4, so the first thing is 6. Negative 4 plus 2, so negative 2. And then 12. Okay? So that's what you get. But now, I have to go back to this is under basis A, but I need the answer in basis B in order to work out in this coordinate. So let's change that into basis B. So how do we do that? So you're trying to say that 6, negative 2, 12, that vector is a linear combination of these, right? A, 1, 4, 1, plus B, 1, 2, 0, plus C, 2, 1, negative 2. And that one gives you A plus B plus 2C equals to 6, 4A plus 2B plus C equals to negative 2, and then A plus no B, but negative 2C is equal to 12. Now you can just solve this. Yeah, maybe it's not too hard to solve it. I'll just use RREF. 1, 1, 2, 6, 4, 2, 1, negative 2. 1, 0, negative 2 equals to 12. If I take 4 times this and subtract, 1, 1, 2, 6 is top, that will be 0. 4 times 1 subtracted from 2 would be negative 2. 4 times 2 subtracted from 1 would be negative 7. 4 times 6 is 24. Subtracted from negative 2 would be negative 26. And this one you just subtract, so it would be 0. And then negative 1, negative 4, 6. Okay, let me switch these two around and then multiply by negative 1 so that it has a 1 and 1 here. So 1, 4, negative 6 is what you get. And now you take double of this, add it here, and I'll just write over here. If you do that, it would be gone. This would be 1. Double of this, negative 12 added to this, will be negative 38. And I guess that means C is negative 38. 38, sorry. And then B is negative 6 minus 4 times negative 38. Oh, I really need a calculator for this.
A is negative 64.
Huh?
A is negative 64. B is 146.
46.
C is negative 38.
Yeah. Okay. A is what?
64. Negative 64.
Negative 64. Okay, good. So here's what we figured out. We figured out that if I multiply this with this, you get this matrix in the representation B, with respect to basis B, of negative 64, 146, and then negative 38. Now what does that tell you? The first column, right? Is that okay?
Say it one more time.
This gives you the first column of this matrix.
Okay.
Right. And then you repeat this for 0, 1, 0. Again, do the same thing. So that's what you do. Is that okay? Alright, so I don't want to do this until the end because one is boring and second I need to show you the second method.
So that's a longer method? Or
I would say longer.
what is this method called? Is there a name for it?
I don't have a name for it. It's just work with the definition. But then the second solution, solution 2, uses the following idea that T B to B is equal to T A to A, but then you have to multiply or conjugate matrices that convert from one coordinate system to another, right? So you go from B to A, but you're not really doing anything to the vector. The vector stays the same, but the representation changes from basis B to basis A, okay? And then another one would be, so what if you feed in a vector with respect to basis B, it's going to get converted into basis A, and then you apply the matrix T, which goes from A to A, and then here you convert it back to basis B. And in both cases I put identity so that I'm not really changing the vector. So that's the idea. All right, so what does this really do? Well, let's think about what this does. Identity, what this does is that if you plug in 1, 0, 0, basis B, All right, where was I? Oh, okay. So, all right, so let's think about what identity that takes basis B to basis A is. Well, if you multiply this by 1, 0, 0, basis B, then this just converts this vector into the basis this. But what does this mean? This means it's the linear combination of these three vectors with 1, 0, 0. So it's really this vector. This vector represented with respect to these three, what is that? That's 1 times this thing plus 4 times this thing and 1 times this thing, right? So I would be getting 1, 4, 1 as basis A. Huh. Seems like I know what this matrix I is. Do you think you know, or do you need to go further? Do you already know what this matrix is?
1, 4, 1, 1, 2, 0.
This is going to be 1, 4, 1, right? And then 1, 2, 0.
And
Then
1,
2, 1, negative 2. Okay? That's what it's going to be. And then afterwards, I'm going to assume that you find the inverse using your calculator, right? Because I just typed up the inverse of this. Okay? So what you want to do is, once you get this, then you want to put this into your calculator and find the inverse of this matrix. And I wrote it down. So, see, I need this matrix as well, right? So what you want is, you want this matrix, A to B. But this will be the inversion of this. So we take this matrix, which is the inverse of this. If you calculate the inverse, it's negative 4, 2, negative 3, 9, negative 4, 7, negative 2, 1, negative 2. That's what this matrix is, okay? So now we have everything. We have this for this matrix for the thing in the middle, and this for that. And we just multiply 3 matrices, and we're done. And you can even do this in your calculator too. So if you do that, you're going to get the answer. Did anyone actually do it with a calculator? Or need you more time?
I'm doing it right now.
Okay. Let's just wait. I'm too lazy. Yes?
So just to reiterate, so
Yeah.
I, A to B is the inverse of I, B to A.
Yeah, because it converts backwards. Yeah. What this does is it takes matrices or vectors that's written in coordinate system A. I say coordinate system because that's what it's really doing. So A is really set of bases, but if you choose a basis, you basically have a coordinate system. Where the standard one is the usual x, y, z. But then if you choose another basis vectors like this one, you end up with some kind of a tilted or oblique kind of coordinate system. It still can manage to represent any point in space with these 3 vectors. That's what's happening. Are we done? Did you get it?
For the augmented matrix, is the last column going to be zeros? When we put it,
No, you're not doing augmented matrix. What you're doing is you have 3 matrices. Actually, just 2 matrices. You have this matrix, call it P, right? So call it P. And this matrix, call it A, right? And then we're doing P, inverse of P times matrix A times matrix P. That's what's, or you can make this into B in your matrix.
so then when we do that vector multiplication, we would get the answer previous, A is equal to negative 64, B is 146.
The first column should have that same vector, or else something's not right. Either we made a mistake in the previous one, or we've made the mistake right now. They have to match. I should have just brought my laptop. You got it?
No, well.
Does the first column match with the previous number that we had? Something in there? No? Can I see?
I was doing it for the one above.
No, this doesn't look right.
No.
Anyone else? We need to make 3 by 3 matrices,
Yes.
not 3 by 4. If you have 3 by 4, you can't do the multiplication.
You get the same thing.
Oh, you got the answer?
Yeah.
Can I see? All right, thank you. Oh, great, perfect. All right. So the answer would be negative 64, 146, negative 38. Recognize that this is exactly the same column that we got in the previous method. And then you have negative 38, 86, negative 22, and negative 39, 86, negative 21. Okay? So that will be the representation with respect to the new basis. That's the answer.